Alright gang, here we go. This is for Chem 2, Unit 11, talking about strong acids and strong bases. Should be a pretty quick, easy, short video. Alright, so strong acids here. Alright, you should remember this from back when we talked about aqueous reactions. Here are our 7 strong acids. You should have these memorized. Alright, a couple videos ago I showed you the way to memorize them. Alright, so those are your 7 strong acids: HCl, HBr, HI, nitric acid, sulfuric acid, and the two, your perchloric acid and chloric acid here. All right. And so these are definitions strong electrolytes. Okay, so they're strong acids because they completely dissociate into their respective ions. So Ha turns into hydronium and A minus. They're so strong they completely break apart. Okay, and so essentially what happens is when you have these monoprotic strong acids, the concentration of hydronium is simply equal to the concentration of the acid. All right, and then for the one diprotic here, acid, the H2, remember di means 2, so this diprotic acid, the concentration of the hydronium is just equal to 2 times the concentration of the sulfuric acid. More or less. Well, that's kind of a fudge. Never mind. Don't rely on that one. Okay. Now your strong bases, okay, are the soluble hydroxides, which are alkali metals, and then the heavier alkaline earth metal hydroxides. So the heavier alkaline earth metals are calcium, strontium, and barium. Remember, their solubilities are low, but they're still strong bases. All right. And then these guys will also dissociate completely in aqueous solution because they are soluble. So they'll form the cation of the metal, whatever metal is attached to an alkali metal or alkaline earth metal, and then they'll form the hydroxides. Watch out for this one. Like calcium and strontium barium hydroxide have 2 of them, so they're going to form 2 hydroxides for each time because they'll dissociate completely into their respective hydroxides. All right, let's do some practice problems here. All right, it says order the following 3 solutions from smallest to largest pH. All right, so to find the pH, all we have to do, because these are all strong acids, all we have to do is take the negative log of each of these. All right, so the negative log the negative log of 0.2 is 0.699. All right, so 0.699. All right, and then the negative log of 0.003 is 2.52. All right, and then the negative log of 1.5. Oops, and this will actually be a negative number, pretty sure, of 1.5. Yep, negative 1.7, negative 0.176. All right, so smallest to largest, the smallest would be 1 or 3, and then 1, and then 2. So 3, 1, 2. Answer C. There's your winner right there. All right, practice exercise 2. It says an aqueous solution of nitric acid has a pH of 2.34. What is the concentration of the acid? Well, we know that the negative log of the concentration of H plus is equal to our pH. Okay, so that means the concentration of the H plus is equal to 10 to the negative pH. All right, so that means the concentration of our H plus is equal to 10 to the negative 2.34. All right, so 10 to the negative 2.34. We get 0.00457, so this would be 4 point, how many sig figs? 2 sig figs, so 4.6 times 10 to the minus 3. And because it's a monoprotic strong acid, this concentration is equal to the concentration of your acid. So there's your answer. Fun stuff. Fun. All right. Order. So this is the pH of a strong base. All right. So this guy, order the following 3 solutions from smallest to largest pH. All right, and they give us the concentration of the base here. All right. Now remember that pH plus pOH is equal to 14. So in order to find the pH, we'd have to take 14 minus the pOH. All right, so the pOH here is 14, is the negative log of the concentration of OH minus. Okay, so for the barium hydroxide, okay, so we'll say I, so that would be our pH would be equal to 14 minus the negative log of the hydroxide concentration. And this is the one I told you to watch out for, that 2 right there. So this is 2 times the concentration of the barium hydroxide, so 2 times 0.03. how many parentheses did I need? All right, so we say 14 minus the negative log of 2 times 0.03. All right, so I got 12, how many sig figs here? 2 sig figs, 12.78. All right, and then 2 here, same idea. pH is equal to 14 minus the negative log of 0.04, and that's just there's just one of those hydroxides you're going to make, so you just do that. So it would be 14 minus the negative log of 0.04. So you get 12.62. Ooh, that's close. 12.60. All right, and then 1, 2, 3. All right, so our pH is equal to, oh shoot, why am I even doing that? We know 3 is going to be equal to 7 because it's pure water. So our pH is going to be equal to 7. All right, nice. Okay, so smallest to largest pH. Smallest pH is 3, so we're looking for a 3 in the front. Our only we got E and C are options, so it goes 3 and then 2 and then 1, so 3, 2, 1, so it's got to be E. All right, cool. So that's it with this stuff. I mean, biggest trick here is just making sure that you're paying attention to how many hydroxides you're making on those bases. Don't fall for that trick. That's a common one students fall for. Next video here is when the math is really going to start getting hairy. We're going to start talking about Ka using all that equilibrium ice table stuff that you mastered in the last unit when we talked about equilibrium. So do your practice problems. Let me know if you have any questions, and I'll see you on the flip side.